Moving charges and magnetic fields. In chapter 120 we have studied about electric fields and what happens when charges are there in electric field, they get a force and all that. So first of all we are just going to talk about what Oersted did. You have studied this in 10th also. Is that Oersted discovered that there is some link, some connection between a current and magnet. Correct? A current carrying wire can apply some force on magnet, so that's why the magnet will move or needle will turn if current is flowing. Right? You would have studied that in 10th standard. And he discovered it purely by an accident. Okay, he had no plans to do anything like that. Then we come to a question. If that Oersted found out that current can apply force on magnets, correct or not? Current can apply force on magnets. But we know what is current. What is the meaning of current? Electric current means flow of charges, that is moving charges. Yes or no? Electric current means moving charges. So basically moving charges can apply force on magnets. Right? Is the reverse or the converse of this true? That is, can magnets apply force on moving charges? Right? Can magnets apply force on moving charges? That's what is the subject matter of half of the chapter. Understood? Question is clear or not? Suppose you put a magnet somewhere and then the charge is moving inside it. Will there be a force acting on that moving charge because of the magnet? So far we have seen that charges get one force. Which force? Due to charge, which force acts? Electric force. Correct or not? Due to mass, which force acts? Gravitational force. So now here we are talking about another type of force on charges which is not due to electric field but due to some magnets or due to magnetic fields. Understood? Magnets create their own magnetic field. Correct or not? So basically this question or this idea is about how do magnets interact with charges. So far we have only seen how charges interact with other charges. They apply electric forces on each other. Correct? Chapter 1 to my also charges create electric field. Electric field applies forces on other charges. So in this direction, a person whose name is Lorentz did a lot of work. Amazing what I've written so far. Okay. So because of his work, today we know a lot about the interactions between charges and magnetic fields. The name Lorentz, name of person. So we can say he discovered something called Lorentz Force. What is Lorentz Force? It is very simple. It is the net, means total electromagnetic force acting on a charged particle. Total or net electromagnetic force acting on a charged particle is called Lorentz force. Basically, Lorentz force is nothing but electromagnetic. So, electromagnetic force is it is the addition of electric force and magnetic force, right? Okay, net electromagnetic force acting on a charged particle. So here is the formula of Lorentz force. A Lorentz force is formula, or you can say electromagnetic. Fill formula is cross product. Okay, this is the formula of Lorentz force. You might find a part of it familiar. આ main formula છે. Have you understood this step? Yes. What have I done? I multiplied Q inside. Okay. Do you know this? Yes. What is it? Electric force. So this is the electric force acting on that particle. Okay or not okay? And the remaining second term is the magnetic force. So you know when we say electromagnetic force, there's no meaning to that. Electromagnetic force is this addition of electric force and magnetic. Do you understand? Right? Electromagnetic force means addition of electric and magnetic force. So आने compare करो तो F is the QV vector. Very good. We know. So FM, what is FM? QV vector cross V vector. Is it fine? Sure. Understood this? तो कोई मुझे Lorentz Force ની formula सुनो तो आने बोलता this the first okay and a magnetic force ની formula Q V vector cross V vector. Is it okay? Now what is B and what is E? तो तुमने खबर है E for electric field, right? Other terms, let's write it down. So we have the following observations about this. Here you will say Fe is nothing but the electric force acting on the charge, which is due to electric field, of course. Electric force is obviously due to electric field. So that's how much Q into E vector. What is Fm? It is the magnetic force acting on the charge due to the magnetic field. Understood? Magnetic force acting on the charge due to the magnetic field. So this magnetic force Fm vector separately લખું કારણ કે આ યાદ રાખવું પડશે થોડું તમને ઓલરેડી આવડ્યું. This is the formula of magnetic force on a charged particle. Any formula there? Magnetic force on a charged particle. Fm vector equal to Q V vector cross B. Can you do a bracket here? Sure. Doesn't make it wrong. No karo to then also not wrong. Don't worry about it. Okay? Fine. What is all these terms? Q तो करने का पड़ेगा लखना मिल जाते. What is Q? Charge of the particle. V vector stands for velocity of the particle. And B vector stands for something called magnetic field. Just like there is electric field, there is also magnetic. So remember that Lorentz did this by experiment. It was completely empirical. Empirical એટલે એને ખબર નહોતી why this is true. Okay, he did not know why this is true. બાકી આનું proof તો ઘણું આગળ deep માં. Okay, this can be only explained by theory of relativity and nothing else. Right? That is, what is magnetic field and what is its relation with electric field? If with a connection to anybody else, that can only be done by theory of relativity. Okay. Anyway, coming back to the point here is that Fm vector is Q, V vector cross B vector. V is the velocity of the particle and D stands for magnetic field. The Lorentz experiment here, I'll just give you a little bit of idea about it. We can create electric fields in various ways. For example, you take two large plates. Our questions they are suppose one plate is positively charged and the plate is negatively charged. So if have the electric field created there, yes or no? And then apart from that, you put two magnets here. Let's say a very strong magnet with north pole on this side, and here suppose another very strong magnet with south pole on this side. And you know that magnetic field lines are there. They go from north to south. Standard north they come out from north and go to south. Magnetic field lines are. So there will be a magnetic field in this type. Did you get that? Apart from that, there will be an electric field because of the positive and the negative charge. So our region must. Which field is there in that region? Is there electric field? Yes. Is there magnetic field? Yes. So we say that there is electromagnetic field. There is electromagnetic field, and whenever a charged particle is inside that, you will get both the forces, one due to electric field and one due to magnetic. Baki gravitation ne એવું તો બધું હોય તો હોય જ. Understood? Okay, meaning of whatever we are writing is clear. આ part તો તમારા માટે સહેજે નવો નથી. I hope you get that. જે હતું એ આ જ. What it? Okay, the total is called electromagnetic force, and only this one, that is called magnetic force acting on the charge particle. Fine. Okay. Now let's discuss some important observations and points regarding the magnetic force. આ chapter માં આવું તો બધું આવતું જ રહેશે, cross product ને. Okay. Now, so talking about important relations or points about the v vector cross b vector term in FF. પહેલા બેઝિક યાદ કરાવી દો ને ક્રોસ પ્રોડક્ટ ના. એ વાંચીને આવ્યા છો? વાંચીને આવ્યા છો? યસ. શ્યોર? યસ. વાંચો ને એક પર આપણે રિવાઇઝ કરી લઈએ. Okay. So when we write a vector cross b vector, this is called cross product or vector product. Yes. You want to find direction, so right hand thumb rule કરવાનું ને, યાદ છે ને કેવી રીતે કરવાનું? Put your open fingers of the right hand in direction of a vector, then try to close them towards b vector, but through smaller angle. આમ નહીં જવાનું. Is that clear? Close them through the smaller angle. એટલે આમ કરવાનું. When you do that, palm will get closed, and the thumb points towards the direction of a vector cross b vector. યાદ આવી ગયું? ઓકે, ત્યારે ખબર નહીં ઓનલાઈન માં કેટલું સિરિયસલી લીધું હશે. ઓનલાઈન હતો કે નહીં? ઓકે. રોટેશનલ મોશન ઓફ ધ ઇક્વેશન. This chapter depends very heavily on cross product. એ પહેલા જ બોલ. બરાબર? એટલે આખા ચેપ્ટર માં ક્યારે હાથમાં ઇન્જરી ન થઈ જાય એનું ધ્યાન રાખજો. નહીંતર પછી તમે કરી નહીં શકો. Okay? Fine. One more thing. If angle between these two is theta, then the magnitude of a vector cross b vector is a b sin theta. Yes or no? Yes. Let us do a magnitude. Direction तो खबर तो पड़ी गई आप करवाओ मेरे लिए. Fine. Cross and dot. Do you remember these? Yes. Cross means inside the board or inside the paper wherever you are drawing, and dot means outside. Cross inside and dot outside. Is it fine? Okay. Fine. Let's start with some important points. Okay, so important points about FM. FM એટલે FM radio thing, magnetic field. First one, FM depends on velocity of particles, which is completely different or unlike electric force. Yes or no? Electric force on a charged particle. So our formula Q into E. Electric force on a charged particle. Q E vector. બરાબર ને? Does it depend on velocity of the charged particle? No. Just the charge and the electric field. હવે આ depends on velocity. કેતે ખબર પડી? Formula શું આવે છે? Fm vector equal to Q V vector cross B vector. So it depends on the velocity. Understood? Second, Fm vector always perpendicular to velocity, and also Fm vector always perpendicular to the magnetic field. સમજાણો કે ન સમજાણો? આ cross product ની property. જો ફરી જો કે રીતે થાય, suppose આ V vector and this is okay V vector બરાબર. Okay, this is V vector and B vector. So V cross B કરો તો ક્યાં અંદર આવશે? Yes or no? Yes. Inside the board. Cross આવે છે? Sure. અચ્છા તો cross એટલે આમ અને B vector કે બાજુ? આ બે વચ્ચે છે. સમજાણું? Okay. હવે v વેક્ટર અને fm વેક્ટર. Where is fm? fm is cross. fm is cross for example. So fm આમ અને v વેક્ટર આમ સમજે ને? I hope you are seeing that. So બે વચ્ચે શું આવે? જે 90 આવે ને, if you cannot see, I have to draw like this, then you will be able to see. દેખાય 90 તેને દેખાય. ઓકે તેને આમ જો મેં પેરું નથી હો કઈ cheating not કરી. This is exactly what it is. Okay or not okay? So બે વચ્ચે શું એંગલ આવે? 90. So always fm vector and v vector are perpendicular, and always fm vector and v vector are perpendicular. There is no exception. Clear? For a charged particle, this is always true. Yes.
સર એ તો n hat ની પ્રોપર્ટી જ નથી જે ક્રોસ પ્રોડક્ટ માં
What?
ક્રોસ પ્રોડક્ટ માં જે n hat આવે છે
એની પ્રોપર્ટી છે of course. એના કારણે ઓકે ઓલ ધીસ ઇઝ બેઝિક. આમ તો હું તમને કહું કે તમને બધા બેઝિક યાદ હોય તો આ કઈ છે જ નહીં, તમારા માટે કઈ નવું નથી. તો ઓબ્વિયસ આમ જ આવે, બરાબર જ છે, આવું જોઈએ એવું લાગશે તમને. ઓકે if you remember all the properties of cross product. Third, अच्छा આપણે મેગ્નીટ્યુડ નો લખ્યું ને, બાકી દેખો મેગ્નીટ્યુડ લખવાનું છે જગ્યા કોઈ લખ નાખો, નીચે અહીંયા લખ નાખો. ઓકે મેગ્નીટ્યુડ ઓફ આ બધા પોઈન્ટ યાદ રાખવાના છે. મેગ્નીટ્યુડ ઓફ fm બરાબર ને, fm equal to q v b sin theta or theta angle between v vector and b vector. Yes or no? Angle between v vector and b vector. So this is the formula of magnitude of force on a charged particle. Magnitude of the magnetic force that is acting on the charged particle. Number 4. આની ઉપર જ છે. If v vector and b vector are parallel meaning what the angle between them? 0. That is theta equal to 0 degree. Or antiparallel. Antiparallel means angle between them is 180 degrees, right? Opposite to each. Then what will happen? Fm will be equal to 0. Clear? Then Fm will be equal to 0. Kyo vichitra force hai. Do you realize what I am saying? Because it depends on velocity. If the charged particle will be stationary, then no force will act on that charged particle. It will sometimes take nothing else. If velocity is 0, lucky number 5. If particle is at rest, that is v vector equal to 0. Velocity speed is 0. Then Fm is also 0. So if charge will move, only then force will act. And even then if charge will move in direction of field, magnetic field, then also force will not act. Understood? समझ पड़ी कि नहीं? अब the concept test થશે ને questions માં. They are very useful. આ બધું લખાયું. Okay? Fine. So this is some property about magnetic field, magnetic force. Now I just want to elaborate on number 2 a little bit. Let me see this understand. But suppose a case is there where you have got electric field towards the right side, electric field, and here is the charged particle Q. Suppose this Q is positive. So in which direction will force act on this particle?
right side.
Left side, right side?
Right side.
Okay, right side, along electric field. What if the charge was negative?
Left
side. Opposite to the direction of electric field. बराबर ने?
Yes.
Magnetic field में क्या करोगे? Suppose this is magnetic field line. ये electric field line और magnetic field line है. Many properties are similar. Okay, and here there is a charged particle, let's say proton or some positive charge, which is moving in this direction. And a force able to right side or left side or upward or downward or where? Dot cross 0.
Cross also cross.
This is positive charge.
Cross.
Moving in that direction. Magnetic field is right side. So, koi baju porta?
Cross.
Right hand use करनो समझो left hand.
Cross.
Cross આવશે ને?
Yes.
નહીં આવે?
Yes.
ન સમજાતું?
Right.
V cross P કરવાનું ને તો V cross P કે બને અંદર જાય છે ને clear or not clear?
Yes.
Sure. 0 તો નહીં આવે કારણ કે એંગલ બે વચ્ચે 180 નથી અને 0 got it. So force will be there and that force will be inward. So magnetic field કઈ બાજુ છે? અને force કઈ બીજી ડાયરેક્શન માં perpendicular to it. Did you understand? This is very different behavior from electric field. Don't you think? Electric field માં કેવું છે? જે direction માં field હોય એ direction લાગે or opposite if the charge is negative. આમાં it will act in a different than perpendicular direction to the magnetic field. Clear? Sure? Okay. एक हजी वस्तु practice one. Suppose that there is a magnetic field like this everywhere. બધે જે પણ કેટલે ડ્રો કરી શકો બધા ડ્રો ન કરી શકાય ને. So this is magnetic field cross. સમજાણું?
Yes.
In which direction is magnetic field? Can you imagine?
Yes.
Going inside everywhere. Okay, any direction. Here, if there is one proton, and proton has a velocity at some time in this direction. When you call magnetic force, what's the direction of magnetic force? What will be the direction of magnetic force acting? Right hand thumb rule use કર્યા વગર તો possible જ નથી. બધાને કહો છો શરમ આવતી હશે તો તમે આ ચેપ્ટર નહીં શીખી શકો, સ્કીપ કરી દો. 8 ચેપ્ટર માં આવજો પાછા. બરાબર?
Left side. Left side.
Left side
Yes.
or right side?
Left side.
V કઈ બાજુ છે? ઉપર. D કઈ બાજુ? અંદર. તો V cross P આમ થશે ને? So it will be towards the left side. Understood?
Yes.
Okay. Sure?
Yes.
Okay. So the magnetic force on this proton will be towards the next one. Listen to it. Now, if we place an electron here at this point, if we place an electron at that point, what will be the direction of magnetic force acting on that electron?
Right side.
Zero also. Velocity.
So,
Sir, એને velocity નથી તો zero no.
બોલો તો clearly. તો બોલો, if we, what did I say? If we place an electron at that point, then what would be the direction of magnetic force? So, pehla velocity ne શું? Is velocity there? If we place that electron, velocity would be zero. સમજાણું? Velocity zero. Magnetic force
Zero.
Understood? Now, if electron has an initial velocity upwards, then what would be the direction of magnetic?
Left side. Yeah. Left side.
Left side is also sure?
Yes.
No. Let's look at the formula. What's the formula? Fm vector equal to q v vector cross v vector. अच्छा, તમે આમ રાઈટ હેન્ડ થંબ રૂલ થી ફાઇન્ડ કરો છો ઈ શું છે? f e v vector cross v vector છે. Think about it. V vector here, v vector inside. So v cross v equal to left side. So far, so good. Everyone's got that. This thing is in which direction? Left side. Yes or no?
Yes.
But this time we are talking about the charged particle which is electron, and electron is positive or negatively charged? Negatively charged. That's why this charge is negative. So minus sign. Vector ma minus sign to करे.
Opposite direction.
Reverse is or gets the opposite direction. So the magnetic force acting on that electron will be in which direction?
Right side.
સમજાણું? સમજાણું ને કે ન સમજાણું?
Yes.
Sure? આવી રીતે થાય. So one property is similar. જે electric force માં એવું હતું ને, positive charge and negative charge get force in opposite directions. એવું જ આમાં છે. If everything else is same, the positive and the negative charge get force in
Opposite.
opposite. Is it fine?
Yes.
जैसे यार આ બહુ કોમન મિસ્ટેક. ઇલેક્ટ્રોન હોય અને તો એ રિવર્સ કરવાનું ભૂલાઈ જાય. કારણ કે v cross v તો આપણે કરી નાખીએ તરત, પછી એવું યાદ ન આવી ગયું આ તો ઇલેક્ટ્રોન હતું. Understood? Fine. Okay. Time for a brain teaser. બરાબર ને? This will test your geometry knowledge also. Geometry અને થોડું maps ને એવું તમને કેટલું ખબર પડે બધું ચેક થઈ જશે. Ready? An electron is fired in gravity free space, okay, towards southeast. Okay, an electron is fired horizontally. Electron is fired horizontally in gravity free space towards southeast. समझा ना समझा? याद ना खबर पड़ी? A magnetic field exists in that space. Okay. In the upwards direction. Find the direction of force. Find direction of magnetic force on electron. Thank you. Wow. And I get the point with that. Okay, we got an answer. સાચું નીકળવું જોઈએ બે વાર ચેક કરી લેજો મિસ્ટેક ન થઈ જાય કઈ નથી કરવાનું you just have to be careful ચલો હર્ષલ ને પહેલા ચાન્સ આપીએ શું કહે છે સાઉથ વેસ્ટ who agrees you agree નહીં બીજો આન્સર what's your answer બોલો
Northeast.
northeast your answer Kevin
East.
east your answer Rohan northeast
Northeast.
northeast
Northwest.
northwest Tisha northwest Tapan east Jay
Northeast.
northeast and are others clueless એવું થયું કે ખબર ન પડી કે કઈ રીતે કરવું કઈક આન્સર તો આવ્યો ને કે ન આવ્યો કઈક આવો તો જોઈએ સાઉથ વેસ્ટ પાર્ટી ચેન્જ okay sit down everyone let's see so it's given to us that the electron is fired towards southeast in gravity free space એટલે આપણે ઉપરથી જોઈએ ઉપરથી like you are watching a map so map માં કેવું હોય east that side west here north here and south here okay magnetic field is in which direction
Southeast.
Magnetic.
magnetic field is in which direction north
Upwards.
north કે upward
Upward.
તો આમાં આ પિક્ચર માં કેવી રીતે ડ્રો કરું
Dot.
dot clear or not clear magnetic field is dot everywhere clear so far
Yes.
બરાબર ને upwards એટલે north નહીં એટલું તો ખબર જ ને તો વાંધો નહીં આવે okay so magnetic field is coming out like this એવું થયું ને અચ્છા અને velocity of electron is in which direction
Southeast.
southeast arm velocity so we use pen to help દીદી લાવે ગમે તે દે ને વાંધો નહીં okay so this green pen is velocity બરાબર અને આ magnetic field છે magnetic field is coming out આવું છે ને તેનો ક્રોસ પ્રોડક્ટ કરવાનું શું કરવાનું v cross b તો પહેલા v cross b ક્યાં આવશે
Southwest.
v cross b પહેલા આ v છે હો અને આ b છે એટલે આ બાજુ હશે okay so v cross b's direction will be southwest yes or no
Yes.
આ કોઈને ન સમજાણું હોય તો આ તો કરો this is only v cross b's direction not final answer is this absolutely clear ઓકે બરાબર ને હજી એકવાર કરી દો આમ v નીચે છે અને b આમ બહાર નીકળે છે આમ કરવું પડશે હાથ આમ કરશે એટલે આ બાજુ આવશે that's what this is તમારી લેફ્ટ સાઈડ માં અને તમારી નીચે જશે લેફ્ટ સાઈડ માં નીચે એટલે ક્યાં આવશે સાઉથ વેસ્ટ સાઈડ in this map got that
Yes.
okay this is b cross b what's this particle electron negative ને તો શું કરવાનું રિવર્સ કરવાનું ને કે નહીં કરવાનું તો કઈ બાજુ આવશે
Not this.
so the correct answer is north east who got it right પેલા ક્યાં તમારે નોર્થ ઈસ્ટ જ હતું કે બીજો આન્સર હતો
North east.
પહેલાથી નોર્થ ઈસ્ટ હતો તો વાંધો નહીં ઓકે એને કોકવાર મગજ ખરાબ થઈ જાય 3D માં આવું બધું થશે this is routine to be very frank બરાબર JEE માં આવી ટાઈપના બધા આમથી આમ કરવાનું આમથી આમ કરવાનું એ બધું આવતું છે ઓકે ચેપ્ટર 5 માં એ અમુક ક્વેશ્ચન્સ માં આવું બહુ થવાનું છે magnetic field આમ હોય પછી આમ કોમ્પોનન્ટ ના okay fine all this is clear turn on the fan okay. Now some important points about magnetic field અત્યાર સુધી magnetic force ના લખ્યું હવે some important points about magnetic field so much is common with electric field to be very frank right so much is common in fact the similarity is so much that is what led people to think what if these two are just two forms of the same thing and that's true they are actually electric field and magnetic field are actually two forms of the same thing right okay so what are some important points about it first of all magnetic field is a vector quantity full range बराबर ने magnetic field is a vector quantity cross product करने का પછી તો વેક્ટર જ હોય ને હવે ક્યાંથી સ્કેલર નીકળે right vector magnetic field follows superposition principle याद है कि नहीं superposition principle okay so just like electric field follows superposition principle magnetic field also follows superposition principle 3 SI unit of magnetic field SI unit of magnetic field is Tesla always written as capital T okay SI unit of magnetic field is Tesla next CGS unit of magnetic field is Gauss capital G આ ચેપ્ટરમાં જેટલા નામ આવશે all of them are very very prominent scientists બરાબર ને ટેસ્લા સિવાય ઓકે ટેસ્લા એટલું બધું કઈ ડિસ્કવર કર્યું નથી of course he did lot of work in magnetic field that's why magnetic field related thing it has his name Gauss तो बोले थे from chapter 1 Gauss बराबर अभी तो बीच में ढूंढ रहे Gauss है derive field okay explain okay what's the relation between Gauss and Tesla well between those two scientists there was no relation of course but between the units one Gauss is 10 raised to minus 4 Tesla बराबर ने one Gauss is 10 raised to minus 4 Tesla actually Tesla is a very big unit okay because magnetic field को rarely नेक्स्ट डायमेंशनल फॉर्मूला ये तो जाते डिराइव करता आवड़े कि नहीं आवड़े केमांथी डिराइव करवानी फ्रॉम दिस fm equal to qvb sin theta બધાને ડાયમેન્શન્સ આવડે ફોર્સ ના ચાર્જ આવડે કે નહીં વેલોસિટી અને sin theta has no dimension બરાબર ને તો this is a trigonometric ratio એટલે ઈ કરી લેજો યાદ તો નહીં રહે કે રાખી દેશો રાખવાની જરૂર નથી હો સહેજ દે કે આવડવાની તો છે જ એના ઉપર તો કઈ પાસ થવાના નથી તમે બરોબર એટલે ઈ તો એમાંથી ફાઇન્ડ કરી લે okay right now we don't really have enough time to cover the next topic